Arcium is the encrypted execution engine of the internet. And my vision for Arcium is for it to become this vast, distributed, almost entirely invisible network that allows everything to be connected, allows information to travel and interact at the speed of light, all while remaining fully encrypted. And 1 year ago at Breakpoint 2024 in Singapore, I introduced and sort of unveiled Arcium. And within the last 12 months, we've been busy building new cryptography, inventing new stuff, implementing all of those things, onboarding builders. And the past couple of months have really been humbling for me and inspiring to see the, almost exponential growth, explosive exponential growth of the number of teams building with Arcium and working on encrypted applications on top of Solana. What has happened, for example, is that Umbra, one of the first teams that went full all in on Arcium, their entire tech being powered by Arcium, the encrypted supercomputer, raised the largest ICO on Solana history on MetaDAO. We've also had thousands of nodes be deployed within our testnet, hundreds of developers building applications for hackathons and deploying those applications. And so this idea of Arcium being the encrypted execution engine of the internet holds entirely true for Solana. For Solana, we serve as the encrypted execution engine, where we are providing the big missing piece to Solana, which is privacy. But we're not just providing privacy to all of our developers and users, we're providing the final form of privacy and computing with encrypted execution. So developers are able to put encrypted data on-chain, but not just individual isolated encrypted data, but what we call encrypted shared state, the unification of everyone's collective encrypted data, and then they're able to run encrypted computations over all of this data without ever anyone seeing the underlying data. And that's what developers love, and that's what we've seen with developers building on top of Arcium, and all of the feedback and usage that we've gotten over the last year has tremendously helped us shape the technology that we are building. And really the symbiotic relationship basically between Solana and Arcium becomes clear when you think about what Solana is. Solana is the internet's execution engine for public shared state. Solana is this ledger where everything happens on this one single shared state. And what attempts at privacy in the past have introduced is more of a Web 2 model of execution, which is running on isolated encrypted state, where secrets remain in the custody of different parties, have to remain there, cannot be shared, and there's no interaction taking place between those secrets. And that's why we're doing encrypted shared state with Arcium, where we can encrypt all data and then run encrypted computations over all of that data without having to see that data. What we've also built, and what I'm most excited about for 2026, is CSPL, the confidential SPL token standard, which enables us to bring the final form of confidentiality to Solana, which means that for any existing token on Solana, we can encrypt the balances and encrypt the transfer amounts and hide all of that information from the public. And the reason why I'm so excited about CSPL is because in my mind, I might not be 100% objective in that regard, but in my mind, it's the most advanced token standard to ever be conceived on top of our public blockchain, simply because we're not just enabling you to take any existing token, make it confidential, have privacy, but for the first time ever, we have confidential smart token accounts, which means that for the first time ever, an on-chain program, a literal smart contract, can have confidential balances and perform confidential transfers. There's no private key associated. It's literally a smart contract on chain that can be used to manage tokens, where there's not a single human being or a single computer in the world that knows how many tokens this account holds. And this smart contract can then perform confidential transfers. And this really opens up a new design space, especially considering that the interfaces that we've designed are as close as possible to the existing public token standard. So you're literally just switching the context between public and confidential and can build anything on top of that. And so we are going live with CSPL in Q1 of next year, and will enable developers, applications, wallets, dApps, all to add confidentiality to their existing stack with no complexity at all. And the design space that we're opening up with this is what we call encrypted capital markets, which sort of is the logical culmination between internet capital markets, encrypted execution, and institutional finance, where we can have anything ranging from confidential transfers up to confidential lending, confidential markets. And then the huge unlock that we are bringing is that thanks to encrypted shared state, we have different confidential markets, but differently from what was previously possible within traditional finance. Now with encrypted shared state, we can execute and settle across all of those venues within a single encrypted execution, because within this encrypted execution, all of those trading venues are literally lit venues. And that's a huge unlock that's only possible with Solana and Arcium, and will bring the entirety of institutional finance on-chain. Now, all of this is possible because within the last year, we've built the Cerberus protocol, which powers Arcium at its core. That's our encrypted execution engine within the execution engine, I guess. And Cerberus is the first ever dishonest majority protocol out there. And what that means is that within our encrypted computations, we always only require one single honest participant within this distributed computation. And that's a huge game changer, considering that previously you always required an honest majority to participate. And we made that practical through some cryptographic breakthroughs. And under the hood, it's very mathematical, very complex. Me, myself, I don't understand everything. Luckily, I have some of the smartest cryptographers and PhDs in my team. But luckily, no one needs to understand how it works, because we've built abstractions on top of that. We've built Arcus, the first ever Rust compiler for encrypted computations. So as a developer, what you're doing is you utilize something like CSPL to simply call create account, transfer, and pass on encrypted value. That's it. And your signature, nothing more. And with Arcus, you write normal Rust code. It's encrypted. You don't have to worry about anything. Now, we're not just the most trustless and versatile encrypted computing protocol, but we've also built the most scalable encrypted computing protocol within the last year. We beat state-of-the-art solutions by orders of magnitude. What that means in practice is that instead of being able to perform maybe 20, 30 confidential transfers per second, we can perform, based on how you measure that, tens of thousands, if not millions of encrypted operations per second. And Arcium itself also excels in regards to ciphertext size. So we've designed Arcium in a way where it's as composable as possible, where you can store every single piece of encrypted confidential data directly on chain and have it interact with the public context, and you can switch between both, simply because our ciphertexts, our encrypted data are as small as possible. Everything can be stored directly on Solana. Everything can be within your on-chain program, and you can build those amazing new applications within this design space that we're opening up. That's everything I wanted to share with you today. Let's encrypt everything and compute anything. Thank you very much.